Welcome to February 20th LeetCode Challenge. Remove covered intervals. Given an array of intervals where intervals at index I is equal to the list, the array of L at I, R at I, representing the interval, strict interval of L at I to the open interval R at I, remove all intervals that are covered by another interval in the list. The interval A to B, so we have a strict start at A and it's open B, so that means it's inclusive A and not inclusive B, covered the interval of C to D if and only if C is less than or equal to A and B is less than or equal to D. Return the remaining interval, number of remaining intervals. So we have here the input being the intervals is equal to this array here, and we have the output being 2. The reason why is because we know that the interval of 3 and 6 is covered by the interval 2 and 8. Since all the numbers of 3 to 6 can be found within 2 to 8, therefore we remove it. Therefore we have this interval and this interval left. Let's look at this interval here. So say we have interval 1 to 4 and then 2 to 3. We know that the numbers 2 and 3 can be found within interval 1 and 4. Therefore, we remove 2 and 3, therefore we're left with 1. So our constraints are that we have 1 to 1000 for length of intervals. We have length of intervals at index I is equal to 2. So L at I is greater than or equal to 0, which is greater than or equal to R at I, which is less than or equal to 10 to the 5th. All given numbers are unique. So for this, we best to kind of sort the interval first. So we sort all the intervals by increasing order. Let's do that at the moment. So let's redefine interval to be intervals to be sorted intervals. So now that the interval is sorted, we just let's set up an index here. So this is going to keep track of our index of where we're at. So let's do a while loop to loop through each element in our interval. So while I is less than the length of the interval, -1. So what we're gonna do, we need to define A and B and C and D. So let's do that. So A and B, that's gonna be an interval index I, and then we're gonna have C and D assigned to intervals at I minus +1, which is the interval before it, so which is the next index afterwards. So basically you want to check if we sort everything out by the intervals. So if we want to check whether this interval belongs within this interval, or essentially, that's the idea. So we'll follow the definition, the question there, give the issue statement, if and only if. So the first one is if A is less than or equal to C and D is less than or equal to B, then we want to remove the interval. Remove intervals at index I +1. So this is saying that, say for instance, if this interval A here, that's not a good example actually, but say A is less than C, right, and we know that D is less than B, therefore we have to remove this interval here, right, if it's contained within the other interval. It's not a good example, but actually no, this is a good example here. So if we're at this index, we see A is less than C, right, which it is, and we know that D is less than or equal to C, D I should say, B, then we remove this interval because it's contained within it. Okay, and then else we gotta do it if the interval before or the interval at index I is within our current interval. So let's say that C is less than or equal to A and B is less than or equal to D. Therefore, we have to remove else if, I should say, not else. And then we want to remove the interval. Remove in the interval at index I. And then we want to increment our interval. And we increment. Let's see. So if this happens, we also have to increment I as well. So I would be minus I. That. Decrement I, should say. Decrement I again. If nothing happens, decrement I. And then there's the loop and return the length of intervals. So this happens when we remove all the intervals. So this should give us back something decent. Intervals. Let's see. Let's see. Sword. We're gonna increment I here. Because that won't work. Alright, looks promising. So ideally, if we use the sorted algorithm, we're using a space time complexity of big O n log n. Even though this is n log algorithm, what's called linear time complexity. The sorted algorithm is maxed out at n log n. And memory complexity is that we basically pretty much manipulate the intervals, so we sort it, and then we remove stuff from it, so it'll be big O of n for memory complexity. Alright, that's it, guys. Have a great day.